I guess I was asked a couple times how these numbers show up in 1.5. How do they get these numbers 1, 1, 3, 12, and 6? I'll show you the reasoning for this. I'm not sure if I agree with it, but we'll go through this and learn a couple things as we do this. So if we were to look at the number of ways I can order a bunch of elements. So if I was to look at the number of ways to order three elements, so let's add A, B, and C, for example. So I have A, B, and C, and I want to figure out how many words, and words are I'm air quoting here. I can put make out of A, B, C. So the number of orders I can have the elements A, B, and C. What we would find out is there's 6 ways to do that: A, B, C, A, C, B, all the way through. Okay, so there's 6 ways to do that, and one way to think of that is by using what we call the slot method. So when we do that in math, what we do is we say, look, there are 3 spots, 1, 2, and 3, and we ask ourselves how many different elements can I put in each slot? So 1, 2, and 3 slots. In the first slot, I can choose 3 elements, right? So I can choose a letter. So here I choose, let's say I chose A. So I have 3 options here. And then when I've done that, I have 2 options for the second element. So that would be 2. And then once I choose that, whatever it's going to be. So let's say I want A for the first letter and C for the next letter. Then I'm left with B. So there's only one option there. So I go 3 times 2 times 1, which is 6. We call this 3 factorial, 3 times 2 times 1. And n factorial is any number times every integer less than it all the way down to 1. So for example, 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1. And that is the way to order 6 unique elements, okay, with no repetition. So if I had A, B, C, D, I would have 4 times, I'd have 4 letters to choose for the first spot, 3, 2, and then 1. So it'd be 4 times 3 times 2 times 1. Where it gets a little confusing is when we have not elements in order, but elements in what we like to call a circle, even if they don't make a circle. So if I have the letters A, B, C again, so I'm going to stick with these, and I say, how many ways can I order these? Well, I put A here, then I put B here, and then I can put C here, or I can put A here, C here, and B there. So what is happening here is where they are in the triangle or the circle doesn't really matter. It's where they are relative to each other. So I'm going to look at this one here and say, if I am Mr. A here, and B is here, so if I'm looking this way, B is to my right and C is to my left. Okay, so that's how I would consider that. Different than this because I would have C to my right and B to my left here. Okay, so if I'm looking this way, I'm looking down here. Okay, so I would consider these unique. And what happens is when we do this sort of thing, what you find out, and the way I teach it normally, is that if you have A, B, C, or 3 elements, the way to organize them in a circle is actually 3 subtract 1 factorial. Okay, so it's actually, and that's the case for everything, is that if you have n elements and you want to order them in a circle, the way to do that is with n minus 1 factorial. So basically what happens is you have your line here, but there's not uniqueness for this position. So for example, what I'm saying here is this is different than what we did above, because if I said here A, B, C, that's not different than this because I go A, and if I go, let's go counterclockwise, I go to B, and then counterclockwise I go to C, and then back to A. That's what is happening here. I go from A to B to C, and then back to A. So we consider this these two to be the same, but I don't consider these two to be the same. Okay, so the answer that they have here, so what they've done here is they've shown here, so they went through and they showed all the different ways to do 5 elements. And I'm saying that the answer is 4 factorial. Their answer is a little bit different because what they're saying is that this is different than this. And I understand why they're saying that, okay? 1 is beside 2, which is beside 3, which is beside 4, which is beside 5, which is beside 1. And it's the same thing here. 1 beside 2, beside 3, beside 4, beside 5. But is that the same thing? Are these the same thing? Yes or no? I guess that depends on the content, the context of the question. I guess in this case, they're saying that what I've written in purple is the same as what they've written in black. So what we have here is we have something similar to what we looked at above, or sorry, on that last page, where 4 should be a number of ways to put that in arrangement. Should be 3 factorial. This should be 4 factorial. But they're saying there's no uniqueness for counterclockwise versus clockwise, so they're dividing each of these by 2. So this here is 4 times 3 times 2 times 1 over 2. This then would be 5 times 4 times 3 times 2 times 1 over 2. And the next guy would be 6 factorial, so 6 times 5 times 4 times 3 times 2 times 1 over 2. And that's how they're getting these numbers here. Okay? Hope that makes sense. That would be a very difficult one to try to figure out on your own. But that's how they got it. All right. Take care.